Welcome to the first video on module 4. In this module, we have to deal with two important topics. One is correlation regression, another one is curve fitting. First, let us concentrate on curve fitting. Later on, let us discuss correlation and regression. Suppose we have a function defined in the tabular form rather than the functional form, then the procedure of finding the functional relation between the two variables x and y in the form y equal to f of x based on the numerical data on x and y is called curve fitting. The curve y equal to f of x that best approximate the given data is called as the curve of best fit. And there are many methods of curve fitting, and one of the method of curve fitting is the method of least squares. First, let us discuss what is this method of least squares. Suppose we have a set of data, say xi, yi, I varies from 1 to n. And these particular data are expected by some mathematical law, say capital yi equal to f of small xi, I varies from 1 to n. And these capital yi values are called the expected value. Once we take the difference between observed values and that of the expected values, definitely we find some difference between those, and these differences are denoted by capital Ri, and these capital Ri values are called as errors in the estimate. And this method, what we call it as a method of least squares, provides the possible relation between x and y in the form y equal to f of x, such that the sum of the squares of the errors is minimum, that is least. Therefore, that summation Ri square I varies from 1 to n is denoted by S. And here we want this S should be least, or we can call it as minimum. That's why the name of the method is the method of least squares, we can say it as. And for our syllabus, we supposed to go for a fitting of three types of curves. One is called linear fit, or it is also called as a fitting of a straight line. And in this particular section, the equation of the straight line might be y equal to ax plus b or y equal to a plus bx. And the second one is a geometric curve, that is y equal to a into x raised to b. And the third one is, it is called as quadratic fit or fitting of a second degree parabola, whose equation might be y equal to ax square plus bx plus c, or y equal to a plus bx plus cx square. These are the three curves we supposed to fit for a given data. First, let us discuss how we can fit a straight line for a given set of data. And in this case, the curve to be fit is y equal to ax plus b, and let us denote it as equation 1. And with respect to this fitting, there is a set of values which are known as observed values, and we take them as let xi, yi, I varies from 1 to n be the set of observed values. And these observed values are expected according to the law y equal to ax plus b. That's why we denote capital Yi as axi plus b, where I varies from 1 to n as the set of expected values. Then the error in the estimate is given by capital Ri equal to small yi minus capital Yi, and that is capital Ri equal to small yi minus, and capital Yi is given by axi plus b. If you substitute and simplify, we get it as capital Ri equal to yi minus axi minus b, where I varies from 1 to n. Then the sum of the squares of the errors, that S is given by summation Ri square I varies from 1 to n, and Ri value is given by the previous step, and once you take its value, it gives capital S equals to summation I varies from 1 to n yi minus axi minus b whole square. That is denoted as equation 2. In this case, our problem is to find the values of a and b such that the value of s must be minimum, that is least. To find the values of a and b, the necessary conditions are given by dou s by dou a equal to 0 and dou s by dou b equal to 0, and these conditions are followed from the differential calculus. And once we differentiate equation 2, that is yes, partially with respect to a, we are going to get this one, and a it has to be equated to 0. Once we simplify this, we get it as summation xi yi, I varies from 1 to n equals to a into summation xi square, I varies from 1 to n, plus b into summation xi, I varies from 1 to n. Let us take it as this one as equation 3. And the same thing when we differentiate equation 2, that is yes, partially with respect to b, we get it as summation I varies from 1 to n 2 times yi minus axi minus bi into minus 1. Once we simplify this one after taking the summation, we get it as summation I varies from 1 to n yi equals to a into summation xi plus n into b, because here the constant b is added n times, and when we add a constant n times, its value is n times of that constant. That's why the summation of b, where I varies from 1 to n, its value seems to be n into b. Now let us take it as equation number 4. And these equation number 3 and 4 are called normal equations. And these plays very important role in fitting of the curves, normal equations. And by solving these normal equations, we are going to get the values of small a and small b after calculating the required things in the normal equations using the given data. By substituting these values of a and b in equation 1, we get the required curve of best fit. And this is the theoretical part what we have discussed in order to fit a straight line y equal to ax plus b for the given data. And here let us list out the important part of curve fitting, that is normal equations. Okay, suppose if our equation is y equal to ax plus b, the normal equations are summation y plus a into summation x plus n into b. Another one is summation xy plus equals to a into summation x square plus b into summation x. Let us understand how to write these normal equations. Okay, when we know what is a curve to be fit, if it is a straight line, in order to write the first normal equation, take the summation for the equation of the curve to be fit, that is for this one. If you take the direct summation for this, then the first one is summation y, that is here. When we take the summation for the first term on RHS, a is a constant, we write that one as it is, and you take the summation for x, and it is here. And when we take the summation for b, the meaning of that one is we have to add the constant b n times. Its value is going to be n times of that constant. That's why it will be n into b. In order to write the second equation, first realize what x is present in the equation of a straight line. With that x, we have to multiply on both sides. Here, small x is present. First, you multiply both sides by small x, then implement the summation on both sides. When we multiply by x here, LHS becomes x into y. Once we take the summation for that, it will give you summation xy. When we multiply by x here, it will be a into x square. Once you take the summation, a is a constant, take the summation for x square. And when we multiply by x for this becomes bx, b is a constant, take the summation for x. That's the way how to write on the normal equations, because until and unless we write the normal equations, we cannot find the values of the unknowns, that is a and b. Now, once if our straight line is y equal to a plus bx, this is one form of a straight line, and this might be another form of a straight line. Once, if it is a straight line to be fit, we have to write the normal equations. And again, once we follow the same rule, in order to write the first normal equation, first you take direct summation on both sides. That gives you first summation y. When we add a constant n, when you take the summation for a, means when we add a n times, its value is n into a. Once we take the summation for the second one, that is b is a constant, take the summation for x. That seems to be this one. And in order to write the second normal equation, first to look at what x is present in the equation of a straight line. In this case, small x is present. Therefore, you multiply both sides by small x. Then you take the summation for that. Once you multiply by small x on LHS becomes xy. Once you take the summation, it will give summation xy. And once you multiply by x here, it becomes a into x. Okay, a is a constant, take the summation for x, that will be this one. Plus, once you multiply by x here, it gives you b into x square, and b is a constant, and you have to take the summation for x square. That will be the way how we can write on the normal equations whenever the curve fit, for curve to be fit is a straight line, either in the first form or in the second form. That's why in general, to write the first normal equation to fit a straight line, take the summation for the equation of the curve to be fit. In order to write the second normal equation, identify the x in the straight line which is to be fit. With that x, you multiply on both sides. Okay, then implement the summation on both sides. That's the way to write down the normal equation for both, means for the curve to be fit. Suppose when it is a straight line. And in general, once you look at the procedure, the meaning of what we are required to do in curve fitting. And once suppose the curve to be fit is y equal to ax plus b, not only this one, whatever may be the curve to be fit, our job is to identify the constant involved in the equation of the curve to be fit using the given data. In this case, the two constants are a and b. Therefore, in order to find a and b, we are going to write the two normal equation. In general, we can conclude that curve fitting means we have to identify the constants in the equation of the curve to be fit. That's a thing we are required to carry out. That's the first one, that is called as fitting of a straight line. Now there is another curve which is known as geometric curve, and the equation of this geometric curve is y equal to a into x raised to b. That's a curve to be fit. And here, this geometric curve can be fit by converting it to straight line just by implementing or taking log on both sides. In this case, the curve to be fit is y equal to a into x raised to b. Means, in this case also, our job is to find the two constants, namely a and b, using the given data. Let us denote that one as equation 1. Suppose if you take log on both sides, then this results as log y equal to log a plus b into log x. And suppose if we denote each of these above equation terms by like this, that is, let us denote log of small y as capital Y, log of small a as capital A, and small b as capital B, and log of small x as capital X. This results in a straight line, and we know how to write the normal equations to fit a straight line. To write the first normal equation, let us take the direct summation on both sides. Once we take that, it leads as summation of capital Y equal to small n into capital A, because when capital A is added n times, its value is n times of that capital A, plus B is a constant, then take the summation for capital X. In this case, if we observe what x is present in the straight line, that is capital X. It's not a small x. And you multiply both sides by capital X, then you have to take the summation on both sides. Once you multiply by capital X on both sides, then it results as summation of capital XY equals to, when you multiply by x, it gives you capital A into capital X. A is a constant, then it leaves as capital X plus, once you multiply by capital X, it becomes B into capital X square. B is a constant, take the summation for capital X square. And let us denote these as equation 2 and 3. And these 2 and 3 are called as normal equations. And once we find the normal equations, we should be very careful that we are going to get the values of capital A and capital B, not small a and small b. But anyhow, we know the relation between capital A and small a and capital B and small b. We can get the corresponding values of A, small a and small b as follows. We know that capital A is given by logarithm of small a. Therefore, small a is given by e raised to capital A. And we have denoted small b as capital B. That's why capital B equals to small b. With this way, now we got the values of capital A and capital B. Now by substituting these values of small a and small b in equation 1, we get the required curve of best fit. That's why this is the procedure, and you have to keep in mind that the geometric curve for the given data can be fit by converting it to the straight line just by implementing log on both sides. Now, in order to get some confidence over the theoretical part, now let us go with some examples. And the first example flows like this. Fit a straight line of the type y equal to ax plus b for the following data. And the data is given as follows. We have some values for x and we have some values for y as shown in the data. Now, as I told you, first we have to write the equation of the curve to be fit. In this case, the curve to be fit is y equal to a plus bx. Let us do it as equation 1. And the next important step is we have to write the normal equations. And we know the procedure how to write the normal equations. In order to write the first normal equations, we have to take the direct summation on both sides of the equation of the curve to be fit. If you take the direct summation for this, that gives you summation y equal to a into summation x plus, when we add this b n times, that value is n into b. And the second equation, that is normal equation, can be written as, first you have to look at what x is present in the equation of the curve to be fit. In this case, it is small x. Multiply both sides by small x, then take the summation on both sides. When we take the product of small x on both sides, LHS becomes small x into y. If we take the summation, its value is summation xy equal to a into summation x square plus b into summation x we are going to get. Now, first of all, our important task is we have to write down the normal equations. Now, in order to write the normal equations, we need to have some values. We need some calculations, namely, okay, that is first thing we need n, that is number of observations, then summation y we need, then we need summation x, then we need summation xy, then we need summation x square. Okay, therefore, in order to go get those for the given data, let us prepare this particular table which gives the required values of the normal equations. First, you write x, y, xy, and x square. Once you compute these things, for this problem, we find that summation x is 56, summation y is 40, summation xy is 356, summation x square is 524. And the first normal equation is this one. And first I will write from RHS. And in this one, I'll write the second term of that, n into b. And n in this case is 8 into b. Then it is summation x into a. Summation x is 56 into a equal to our LHS, that is summation y. summation y is 40. Now once you go for the second normal equation, again I'll write the second term in RHS, that is summation x into b. Summation x is 56 into b plus, that is 254 into a, 524, that is summation x square into a equal to 354. If we solve these, okay, we are going to get the values of a and b as, that is a equal to 0.6363, that is approximately equal to 0.64, and b is 0.5454, that is approximately equals to 0.55. And once we get these values, okay, we can solve these using the calculators. And once you substitute the values of a and b in equation 1, we get it as y equal to 0.64 into x plus 0.55. We are going to get, these are the values of a and b we are going to find here, which is the required curve of best fit, we can call it as. Once we go with another problem, here the state line is somewhat different. Earlier the state line is y equal to ax plus b. In this case, the state line is y equal to a plus bx. The pressure goes almost same, only there will be a slight change in the normal equations. In this case, the equation of the curve to be fit is y equal to a plus bx. And the normal equations are, that is, once you take the direct summation, it leads summation y equal to n into a plus b into summation x. After multiplying both sides by small x, and if we implement the summation, we are going to get it as summation xy equal to a into summation x plus b into summation x square. And once noting the requirement of the normal equations, you have to prepare this table. Okay, and once we know the values of all the requirements of the normal equations, once we write as, first one is n into a, n is 6, that is 6a, plus summation x is 900, that is 900b equal to summation y is, that is 395. Second equation is 900a, that is summation x into a, that is 900 into a, and next one is summation x square into b, that is summation x square is 1,42,000 into b equals to summation xy, that is 62,100. Using calculator, if you solve these, you are going to get the values of a and b as, that is small a equals to 4.7619 and small b equals to 0.4071. By substituting these values of a and b in equation 1, we get the required curve of best fit as y equal to 4.7619 plus 0.4071 into x. That will be the required curve of best fit, we can say that. Sometimes instead of giving the notations x and y, they will give the straight line in some other notations. For example, suppose if we require to calculate, or if we require to fit the curve r equal to a plus b theta, which is also a straight line in r and theta, with respect to the following data, that is theta and r values are given. Of course, the pressure is same, only thing instead of x and y, we are having r and theta we are having. Therefore, first let us write down the curve to be fit, that is r equal to a plus b theta. And as I told you, the procedure of writing the normal equations. First, take the direct summation for the equation of the curve to be fit, that is summation r equal to, if you add n times, its value is n times a plus b is a constant summation theta. And in this case, the independent variable is theta. Multiply both sides by that, then take the summation. If you do so, it will give you summation r theta equal to a into summation theta plus b into summation theta square. And again, in this case, the requirements of the normal equations are summation r, summation theta, n, summation r theta, summation theta square. And we have to calculate these values with respect to the given data using the following table. Okay, and once we using these data, if you write the normal equations, they are going to be like this. By solving these normal equations using the calculator, we get the values of a as 70.05 and b as 0.2923. And by substituting these values in equation 1, we get the required curve of best fit as r equal to 70.05 plus 0.2923 into theta. That will be the required curve of best fit. Now let us consider the following example where the question is the following table gives the production of a certain commodity in different years, and in this case we are supposed to fit a straight line y equal to a plus bx, and we supposed to estimate the production for the year 2005. And in this case the data is given as follows: years and production, they are given. Years you are denoted as small x, and production you are denoted as y, and they are in some units. And in this case, once we look at the values of x as quite big in magnitude or quite large in magnitude, in order to reduce the magnitude of small x values, now we are going to define one new variable, capital X, and that capital X is taken as value of the variable, that is small x, minus any value in that range. In this case I have taken it as 1958, and the length of the interval between 2 years, in this case it is 10 that I have taken. We can take any value instead of 1958 in that range. And the main intention of reducing the values of small x, which are quite large in magnitudes, to capital X is that if you reduce like this without using the calculator also, we can work out the problem. That is the main intention of reducing the bulk of the data. And without reducing this also, we can carry out anyhow. We supposed to use the calculator and we can handle any big value. But in order to go for the calculation in a simplest form, we are going to reduce the bulk or magnitude of small x values as capital X, taking it as small x minus 1958 divided by 10. Now, instead of fitting the curve small y equal to a plus b into small x, now taking the equation of the curve to be fit as small y equal to a plus b into capital X, where capital X is defined like this. And again, it's a straight line, and we have to write the normal equations. The first normal equation is take the direct summation, that leads as summation y equal to n into a plus b to summation of capital X. And once we observe here, we find that capital X is there in the equation of the curve to be fit, and by this x we have to multiply on both sides, that is summation x capital X into small y equal to a into summation of capital X plus b into summation of capital X square. And they are given in this case small x values, they are given small y values. And we have converted small x to capital X by defining capital X as small x minus 1958 divided by 10. And once you go and take the values for x in this range, we find capital X values are 0, 1, 2, 3, 4. And xy we have to calculate, that is capital X into small y and capital X square, and their total or summation values are going to be like this. Once you use these values in the normal equations and once we solve them, we are going to get the values of small a as 8 and small b as 1.6. Okay, then equation 1 becomes, that is y equal to 8 plus 1 point b into capital X is there, but capital X value is small x minus 1958 divided by 10. Once you divide this 1.6 by 10, it leads to 0.16. Once you multiply and if you simplify, we get y equal to minus 305.28 plus 0.16 into x as the required curve of best fit. And for this problem, we are supposed to calculate the production for the year 2005. Therefore, in equation 2, wherever small x is there, if we take 2005 and it calculates y equal to 15.52 as the expected production for the year 2005. And above four examples are how to fit a state line for different types of state lines, sometimes in terms of x and y, sometimes in terms of r and theta, and so on. Now let us deal one or two problems how to fit a geometric curve, that is y equal to a into x raised to b. Suppose the question is y fit a curve y equal to a into x raised to b for the following date. As this is the data for which we supposed to fit the curve, and as I told you that the geometric curve can be fit by converting it to straight line. That's why once you take the log for this one, it results as a straight line in this format, and the normal equations for this straight line are going to be like this. The first one, direct summation, that is summation y equal to n into capital A plus b into summation x. And in this case, capital X is present in the equation of the curve to be fit. So we multiply both sides by capital X. Then if you take the summation, this will be the second normal equations we are going to get. Once you look at the requirement of the normal equations, which are namely capital Y, summation of capital Y, capital X, summation of capital X, summation of capital XY, small n, and summation x square. Once we calculate those values, x and y are given, and capital X is nothing but your logarithm of small x, capital Y is nothing but your logarithm of small y. And once you go for here, the base is e we have to take, and once you calculate, we get this one. Then the product of these two, that leads to xy, and the square of these, that leads to capital X square. And these are the totals or summations of these values. By taking these in the normal equations, and by solving them, we get capital A equal to minus 0.69315 and capital B equal to 2. And these are the values of capital A and capital B. But our actual intention is to get the values of small a and small b. And we have some relation between capital A and small a, and capital B and small b. We know that capital A equal to logarithm of small a with the base e. This leads to small a equal to e raised to capital A. And once you substitute the value of capital A, it gives the value of small a as 0.4999, that's almost zero point 0.5. And capital B is small b, that one equals to 2. By substituting these values of small a and small b in equation 1, we get the required curve of best fit as y equal to 0.5 into x square. We are good. This will be the way how we can fit a geometric curve for the given data. Now let us go for one more problem on geometric curve. Okay, only the change is, again there will be a change in the notation. Instead of x and y, they have given the curve to be fit as v equal to a into t raised to b. In the place of y, we are having v. In the place of x, we are having t. Again, as we know, the geometric curve can be fit by converting it to the straight line just by implementing log on both sides. Therefore, it leads as log v equals to log a plus b into log t, and it will be of the form capital V equals to capital A plus b into capital T, where each of these capital values have the respective notations, that is capital V equal to logarithm of small v, capital A equal to logarithm of small a, capital B equal to logarithm of capital B equal to small b, and capital D equal to logarithm of small t. And we observe that this seems to be a straight line in V and T, with the T as independent and V as a dependent. And we can write on the normal equations. First one by taking direct summation, second one by multiplying both sides by capital T, then implementing the summation. Once you look at the requirement of these normal equations, we are supposed to first get capital B and capital T, then we have to get summation TV. That's why we have taken V into T. Then summation T square. First, let us take T square. And these are their totals. And once you substitute these values in the normal equations and by solving them, we get the values of capital A and capital B as, that is capital A as 7.0167 and capital B as 0.3511. Now we know the relation between capital A and small a. Therefore, capital A equal to log of small a. Accordingly, we can write small a equals to e raised to capital A and capital B equal to small b, and this will be in this fashion. And by substituting these values of small a and small b in equation 1, we get small b equal to 111, sorry, 1115.1 into t raised to minus 0.3511 as the required curve of best fit. And this is all about the discussion of how to fit a straight line as well as how to fit a geometric curve. Now we left one more curve which is known as fitting of second degree parabola or fitting of a quadratic equation. Suppose if you want to fit a second degree parabola, say y equal to a plus bx plus cx square, let us take it as equation 1. In this case, our job or our requirement is to find the values of small a, small b and small c. Okay, using the given data, we are required to find those values of constants a, b, c. In general, if you want to fit any curve, our job is to find the constants involved in that equation with the help of the given numerical data on x and y. Now, in order to go for this particular fitting, let small xi, yi, I varies from 1 to n be the set of given values. And these values are expected according to this law. That's why let us denote capital yi equals to a plus bxi plus cxi square I equal to 1 to n be the set of expected values. Then the errors is the difference between observed and expected. It is given like this. And once you simplify it like this, then sum of the squares of the errors is denoted by s, and that is given by summation ri square I varies from 1 to n. Once you substitute the value of ri from the above step, we are going to get this particular notation or equation we can get. Now, as I told you, in this case, our job is to find the values of A, B, C such that S is minimum. From the differential calculus, the necessary conditions to find the values of A, B, C is that the partial derivative of S with respect to A, B, C, they must be equals to 0. That is, dou S by dou equal to 0, dou S by dou equal to 0, dou S by dou C equals to 0. Once you find these derivatives and equate them to zeros, and if you simplify, we are going to get these three equations which are known as normal equations, we can say. And by solving these normal equations, we get the values of small abc, and by substituting these values of small abc in equation 1, we get the required curve of best fit. And this is one quadratic equation or second degree parabola, and alternate equation might be like this. In that case, the normal equation seems to be like this. Now I will give the insight how to write the normal equation for a second degree parabola. I think you are familiar how to write the normal equations in case of straight line. In case of straight line, the first normal equation is written just by taking the direct summation on both sides. In order to write the second normal equation, we have to multiply by x present in the equation of a straight line to be fit on both sides, then we have to take the summation. The same thing has to be implemented here also. And one more extra equation is written by multiplying both sides by x square, and we have to take the summation. Because here we are supposed to calculate three constants, namely a, b, c. Minimum we need three equations. That's why I will tell you how to write the normal equations in this case. The first normal equation is written by taking the direct summation for this, which is summation y equal to, once you add this a n times its value is n into a plus b into summation x plus c into summation x squared. That will be the first one. In order to the second normal equation, multiply both sides by x, then take the summation. Once you multiply by x, it becomes xy. If you take the summation, that becomes summation xy. Once you multiply by x, it becomes ax. A is a constant, take the summation for x. Once you multiply by x, it becomes bx square. That is, b is a constant, take summation for x square. Then once you multiply by x, it becomes cx cube. C is a constant, take the summation for x cube. Now, in order to write the third normal equation, multiply both sides by x square, then take the summation. That is summation x square into y. Once you take the summation, it becomes summation x square into y. A into x square, that is a is a constant, summation x square. B into x cube, b is a constant, summation x cube. C into x raised to 4, c is a constant, summation x raised to 4. And this is a procedure to write the normal equation. Either the equation of the curve to be fit is like this, or it may be like this. Here also we can observe the same thing. Once you take the direct summation, you get the first equation. Multiplying both sides by x, if you take the summation, you get the second equation like this. Multiply both sides by x square, and if you take the summation, it will be like this. We are going to get the third normal equations. That's why whatever may be the curve to be fit, it's essential to write the normal equations. Once we write the normal equations, we will realize what the calculation to be carried out for the given data. Then we have to use those data in the normal equations to find the unknowns in the equation of the curve to be fit. That's very, very important. Now let us deal with some examples on the quadratic fit. Let us take the first example. Fit the curve y equal to a plus bx plus cx square for the following data. And first let us write the equation of the curve to be fit. That is y equal to a plus bx plus cx square. Let us take it as 1. As you know, it's very important to write the normal equations. Before writing the normal equations, let us know what is our job in this case. In this case, our job is to find the unknowns in the equation of the curve to be fit. That is namely ABC. Okay, not to find the ABC, that is three unknowns, we have to write the three equations which are known as normal equations. And the first normal equation is given as, take the direct summation, that is summation y equal to, if you add a n times n into a plus b is a constant, b into summation x plus c is a constant, summation x square. Multiply both sides by x, take the summation, you'll get this. Multiply both sides by x square, then take the summation, you are going to get this. Once you look at the requirements of the normal equations, okay, one has to prepare the following table. Means we need the values of n, summation x, summation y, summation x square, summation x cube, summation x raised to 4, summation x square y, summation xy. In order to get these, let us prepare this table, and these seems to be the totals or summation values. And by taking these summation values in the normal equations, we get these three equations. And by solving these, we get the values of ABC like this. Once you substitute these values of ABC in equation 1, we get y equal to 1.42, that is A, plus B, that is minus 1.07 into x, plus C as 0.55 x square as the required curve of best fit. And in this case, the equation of the curve to be fit is y equal to a plus bx plus cx square. And if you take one more example on another form of the quadratic equation, that is y equal to, that is ax square plus bx plus c. And again, first you write the equation of the curve to be fit. Then write the normal equations. First one by direct summation, second one by multiplying both sides by x, then take the summation. To write the third one, multiply both sides by x square, then take the summation. Now, in order to get the requirement of the normal equations, let us prepare this table and take the total or summation values in the normal equations. By solving using calculator, we get these values of ABC. By substituting these values of ABC in equation 1, we get the required curve of best fit. And in the similar fashion, this is one more problem. You can try that in the same fashion what I explained above. Definitely you will get the calculations and you can check the values also. And this is one problem which appeared many of the times in the exam. You try on your own and given the answer also and try to check whether the answers is correct one or not. And this is all about the particular topic, that is second part of module 4, which is known as curve fitting. In the curve fitting topic, we learned how to fit three kinds of curves with the method of least squares. The first one is fitting of a straight line, second one is fitting of a geometric curve, and the third one is fitting of the second degree parabola or quadratic fit. Thank you.